Hello, algebra students, and welcome back to day 3 of the Pythagorean Theorem, specifically the Pythagorean Theorem on a coordinate plane. And this is a coordinate plane, something you're familiar with, a graph with x and y axes, right? And we're going to give you points. And so what makes today, the only difficult part about today is that you might have to sketch out your own little diagram, or the diagrams or the little graphs might be online. Like, it'll already be graphed for you online. And so this shouldn't be a super difficult day, but the whole moving from paper all the way to computer might pose a few more challenges than normal, but that's okay, because we can do that. Can I find the distance between 2 points on a coordinate plane? What we're doing today, there's multiple ways of doing it. So if you're sitting down with an older sibling or someone at home is trying to help you and they say, oh, don't do it that way, do it this way. I don't care. I don't care how you do this, as long as you know how to do it on your own. So if you do it the way I have taught you, that's totally fine. If you do it the way someone at your house does it, that's totally fine as well too. So it doesn't matter as long as you can do this all on your own. So this is the type of problem that we could run into. Find the distance between the points -3, 2, and 2, -2. Now, there are multiple ways of doing this, especially if I don't have graphs for you. You can print out a whole bunch of graphs. If you have some graph paper at home, awesome. And if not, this is how I would personally do it. If I was at home, I'd say, you know what, it's not even worth my time to go in and print this out. I'm going to draw some x's and y axes here. And I'm going to determine based off of these numbers, like where, how many lines I need to create. But because it only ever goes over -3 up 2, over 2 down 2, I don't need to go like up 10 or anything. So I'm going to leave that there. I also like to leave my main axes in pen and then make all the other axes in, or not the other axes, but the lines on the graph in pencil, because it's like lighter to see. Oh, that was horrible. Let me try this again. I'm going to turn it to the side because it's easier for me. Again, if you're like, psh, I'm not going to do this, I'm just going to print out some graphs. Good, go for it. I don't care. But I now have a awesome, great, little bit sketchy line, and that's okay. This graph over here. So we're going to graph these 2 points. I'm going to use some colors. -3, I'm going to try and use a different color. -3, 2, -3 up 2, so that's that one. And then 2, -2. Where's another color? I'll use this one. 2, -2, so over 2, down 2. And I am supposed to find the distance between those two values. And I wish I could count. Like, I wish it was just like 1, 2, 3. But it's not going directly through any of the points, and even if it did, that wouldn't be a good way of finding the distance between them. So this is a foolproof way of doing it. You are going to create a little slope triangle, like you've done before, like where you go down 4 over 5, down 4 over 5, or whatever. You're going to create a little slope triangle. Use any color that you want. I think colors are super helpful. We go directly down and directly over until they touch. You could also do this above. Directly up or directly over until they touch. It doesn't matter. But you have created 2 right triangles. I'm going to use the bottom one though. So in this case, I now have a right triangle that I can use the Pythagorean Theorem for, because this is what I'm looking for. I'm looking for the distance. I'm looking for that measurement. That measurement is my hypotenuse. Do I know what these 2 legs are? Yeah, I do, because if they're vertical and horizontal, I can just count. This is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. So I have a triangle, and I think I've said this probably 20 times since we started our Pythagorean theorem. Draw out the little triangle. If you do a whole bunch of work and you're like, whoa, look at all of this, you can make it look really nice by doing it like a separate piece. So at this point, we're going to find our unknown. We're going to solve for our unknown. A squared plus b squared is equal to c squared. What are we plugging in where? Oops, sorry. C is my hypotenuse, and in this case, x is my hypotenuse. And then a and b, it doesn't matter. 4 or 5, 5 or 4, doesn't matter. Because both of them are legs, and it doesn't matter, both legs are a and b. Lots of ways of doing this. You could just type in 4 squared plus 5 squared into your calculator. It is not 9 squared. 4 squared and 5 squared is not 9 squared. You would have to do it a little bit separately or on your calculator. Add that up and you get 41. How do I get x by itself? Square root both sides. X is equal to the square root of 41. Now, is that the answer that I would accept? And it actually is, because there's no perfect square that goes into 41. 4 doesn't go in, 9 doesn't go in, 16 doesn't, 25 doesn't, 36 doesn't. I'm done. Nothing else goes in there. So my actual length, or if I say what's the distance between negative 3, 2 and 2, negative 2, you say, well, it's the square root of 41 units. Now, that's the correct answer, because it is like an exact answer. If you do want to like just put it into perspective, the square root of 41 is 6.4. And that makes sense, because if we're looking at this right triangle, the two legs are going to be shorter than the hypotenuse. And if my legs are 4 and 5, my hypotenuse is going to be bigger than both of those, but not bigger by a lot. So technically, I mean, if you wanted to say, hey, my answer is approximately 6.4, you would also be correct. That would be your approximate answer. Not exact, but approximate. So let's look at another problem. This is actually one that I've printed out because I want to show you guys exactly what it's going to look like on your like Schoology assignment. So in this case, this is a problem that could be given to you, and you don't actually have to graph it. It'll be graphed. Oh no, I have dog hair. Whoops. It'll be graphed on Schoology. So this will be like a graph that's on Schoology. It's kind of hard to see the lines. You can see it a little bit better there. And it'll look a lot better on Schoology. This graph will be there, and it will say find the distance between the 2 points. And so you are assuming that there is a line between those two, and you're looking for that line. That's your hypotenuse. That's what you don't know. And then mentally or in your head, and again, you don't have this printed out to actually write on it, so in your head you're going to say, okay, I'm going to go over and down, so over and down, and figure out where they connect, and that's 1, 2, 3, 4, 5, 6, 7. So that's a side length of 7 to get down to the blue dot. And then I'm going to go over from the blue to see how far to the red. 1, 2, 3, 4, 5, 6, 7. Ooh, 7. Awesome. Okay. So I have a right triangle. And again, if you want to write this out or draw this out, you totally can. You don't have to. 7, 7, and an x. And we are looking for that distance there. I'm going to tell you it's bigger than 7. Because if this is 7 and that's 7, that can't be 7. It has to be a little bit bigger. But let's plug in what we know and solve for what we don't. So what do I know? Do I know my A and my B? Do I know my C? And in this case, I do know my A and my B. They're both 7, so it doesn't matter which order you put them in. And C is my hypotenuse. That's my x value. That's what I'm looking for. In these problems where you're looking for the distance between the 2 points, you're always looking for C. You're going to do this exact same thing over and over again. So we have 7 squared is 49, plus 49 is equal to x squared. You can do this part in your head like you could have just typed in 7 squared plus 7 squared, and you could have jumped this part and just gotten to 98 is equal to x squared. And at this point, you are asking yourself, what perfect square goes into 98? And you can take your calculator here. 98 divided by 4. Nope. 98 divided by 16. Nope. 98 divided by 25 doesn't work. 36. 98 divided by, Which one am I missing? 49. Okay, so it goes in, 49 goes in twice, obviously, because there's two 49s in it. Get it? Oh my gosh. I always forget those ones. Okay, so we have x is equal to the square root of 98. But if you're like me, you forgot that 49 goes into 98 twice. So we have 49 and 2. But what is 49? That is 7 roots of 2. And I'm going to write it the other way. But that would be how you would solve a problem like the ones that you'll see on Schoology.